And we are back here again to listen to what Adam has to tell us about refactoring legacy code, just in case somebody skipped and couldn't make it for the opening keynote today. Adam Culp is working as a consultant for Zend, and he also runs one of the greatest PHP conferences around, the SunshinePHP conference in Florida. And he does this talk in front of many, many people around the world. It's a very popular thing, and I hope you enjoy it. Pause for Adam Culp.
Thanks for coming. I'm glad you folks came to hear me speak. For those of you who caught my keynote this morning or who listened to another one of my talks, I'm going to do a little bit of repetition here for just a moment as I introduce myself for those who don't know who I am. My name's Adam Culp. You can find me at Twitter at Adam Culp. Now, after I finish the talk, please go out to Joined In and rate the talk. This is talk number 14883. Please go out and rate the talk. I value the feedback on all of my talks that I get from folks. I travel around. I speak at a lot of conferences. I average about 13 conferences a year. Oftentimes, I tell folks it's not a problem to get me. It's not the problem to get me to talk. It's the problem to get me to shut up. So I enjoy talking. So please leave me feedback because I give these talks over and over again at different places, and I use the feedback that I get from folks to tweak them for the next crowd that listens to the talk. So please leave me feedback. A little bit more about me. I'm a PHP 5.3 certified engineer. I work for Zend Technologies. Often when I'm working for Zend, I'm working with customers who have contacted Zend and need help with their architecture. They need help refactoring applications or forming their teams and things like that. I am a consultant, so that's what I do. I don't write a lot of code these days. The code that I do write is generally for open source projects. I contribute to many open source libraries and packages out there. I don't do a lot of code from one day to the next. I don't necessarily like that, but it's a fact. And as a consultant, I spend more time coaching people on programming and helping them create clean architecture versus writing the code. So I get a little bit rusty once in a while. But the biggest thing that I help folks with, the biggest thing that I consult on is refactoring. Refactoring is my passion, it's my superpower. I love refactoring, and I love helping folks refactor. I'll talk a little bit more about that, but I'm on the Zen Certification Advisory Board. So if you're not certified or if you are certified, chances are you answered a question that I helped put on the test or at least reviewed, whether it's the PHP certification or the Zen Framework certification. I encourage folks to get certified. Certification doesn't mean you know everything. That's not the purpose of a certification. A certification is to say, I know enough, right? So we get certified so that way when it comes time to get a new job or to be interviewed, the company can know that we know enough so that we can get up and running versus someone else who says, well, yeah, I'm a PHP developer. Well, what's that mean? Well, I installed WordPress. Well, you're not really, that's not the same, right? But having a certification, you kind of know, okay, well, you know, if I'm certified, I know enough to actually code, right? And so that's where certification comes in. I'm the organizer of the South Florida PHP user group from West Palm Beach down to Miami. We have about 800 members in our user group, and I also organized the SunshinePHP conference in February. If you don't have anything better to do in February, come down and see us in Miami. There's a lot worse places you can be in February than Miami. It's a very cold time of year in most geographic locations. I'm also an ultra runner. For those of you who don't know what that is, a marathon is about 26.2 miles. Ultra means more than. So I run more than 26.2 miles. And I'm also a black belt judo instructor. I teach kids in the local area judo, and so I bring some of these things up because I'm a huge fan of iteration. I love iteration, and it's things that we do on an ongoing basis. Whether we're at long distance running, I didn't just jump off the couch one day and say, hey, I'm going to go run 100 miles or try to run 100 miles. It takes practice. It takes training to get up to that point. Martial arts. Everybody knows martial arts is a lifelong study. It's not something you just know martial arts. You know, you work your way up through the different ranks in martial arts to get a darker belt. and you get more proficient at it. Development is iterative. It's something that we as developers do on an ongoing basis. We do things over and over again, through project management, agile, what have you, and we get better at things over time. Evading project managers, that's iterative. We get better at it as we do it. Refactoring, same thing. Refactoring is iterative. It's something you do in small steps. You do it in small steps, and through refactoring, you improve the quality of your code. And that's refactoring. Now, this talk isn't necessarily one of my refactoring talks. This talk is more about modernizing legacy applications. This is a book by a good friend of mine, Paul M. Jones. Paul wrote this book on modernizing legacy applications. I actually wrote the foreword in this book. So when you read the book, at least read the foreword. But no, to be frank, it's a very good book. It's 250 pages of practical modernizing of an application. In the book, Paul guides you through taking an application that is maybe not object-oriented, maybe it's object-oriented, and he walks you through a step at a time to get to a place where it is front-controlled. You could use a framework if you wanted to, and things like that. Very good book. I encourage you to use it. You can also check out mlaphp.com. And from that site, there's also blog posts and other content related to modernizing a legacy application. Paul is brilliant when it comes to that stuff. I encourage you to check it out. And again, pick up the book, especially if you're modernizing a legacy application. In this talk, I'm only talking for 45, 50 minutes. There's no way I could possibly get you to the point where you can walk out of this room and know how to modernize a legacy application from start to finish, right? It takes time. There's a lot of pieces to it. I'm going to cover the basic key elements of it, so that way you will kind of have an idea of how to do it when you leave. I'm going to show you code. I'm going to walk you through all the practical pieces of it. This book will actually walk you through in a lot more detail than I'm going to be able to cover in this talk. It's a very good book. I encourage you to pick it up. So, to start with, what is legacy code? Well, legacy code, if you're working on a project, and in that project you don't have a coding standard for the project, or maybe the code is not using OOP. Maybe you're not using Composer, so that way you can pull in external libraries. Maybe the code base you're working on is not necessarily using a framework, right? Maybe you're not doing unit testing. Does your project avoid NIH? That means not invented here, right? Where you're writing all the code from scratch versus pulling in other libraries that have already done it, right? You're recreating the wheel time after time. If you can answer no to any of these questions, you're probably already working in a legacy application. Maybe you're creating a legacy application on a daily basis right now, today, because you're not following these practices. You're creating legacy every single day. Every line of code you write, you're already creating legacy. Stop creating legacy applications. Legacy is something you should inherit from some other developer. It's not something you should create, right? So what is refactoring? Refactoring, according to Wikipedia, is the process of changing a computer's source code without modifying its external behavior. So in other words, we're not adding functionality when we're refactoring. Modernizing a legacy application is exactly the same thing. We're not modifying the functionality of the application. All we're doing is modifying the code. We're modernizing the code to make it cleaner, to make it more manageable, to make it easier to enhance later on down the line. But modernizing is not actually changing the functionality, or refactoring is not changing the functionality. It's basically really only enhancing the code quality. As we are developing and refactoring, I like to use the analogy of having two hats. You have one hat, which is your coding hat. That's when you're adding functionality. After you add the functionality, then we refactor, right? Because developers just don't write clean code the first time. We don't write perfect code the first time. At least I don't. Anybody in here that thinks you can write perfect code the first time, see me afterwards. I can pass you off to somebody who wants to hire you. But we as developers, really, we generally don't write clean code the first time. We usually I myself write pretty ugly code initially. I just want to get the functionality done. Once I get the functionality done and get everything finished that I need, then I refactor the code to make it pretty. A quick story. I I started recently contributing to the Ibm I Toolkit. Very old toolkit. It's been around for a long time. It's PHP code, and it uses XML services in the back end. It's how PHP is able to use XML services on an IBM I. You might know it as AS400, right? And the toolkit was very old, very, very procedural in nature. It had some objects, but for the most part, it was procedural. I went in and refactored it over a few days, and I'm still in the process of refactoring it. We're modernizing it as, right now it's on an ongoing basis. And the developer who had been on the project for a while sent me an email, and he said, Adam, I got to tell you, I never thought that this code base would look beautiful, and I'm glad to see that it is. That's what refactoring is. You're making the code better, you're making it more manageable so people can actually work in it from day to day and be able to look at the code and say, wow, that's beautiful, it's art, right? So we don't want to change the functionality. We're coding, refactoring, then we go back and add functionality. We're coding again, then we refactor. And then if you need to, then you optimize. Optimization is a totally separate step. Optimization should not be part of your refactoring. You do not refactor to optimize. You refactor to clean the code. Generally, you are optimizing while you're cleaning the code, because if you're following good practices, generally it's going to be more optimal through the refactor, right? But the goal of refactoring is not to optimize. Optimization is a totally separate step. We do that afterwards if we need to, and that's how we follow that. As one very important item is, as we're refactoring, as we're modernizing, we have to make sure we have source control. Everybody has source control in their code, right? Using it on everything, every bit of source code you have, you're doing source control. And we need to make sure that, because if you're not using source control, then it's impossible to refactor effectively. It's impossible to modernize effectively. The best way that I've found to refactor is I usually create a branch or a feature branch. I do my refactor there, and then I merge everything back into the main branches. That way, it allows us to have a rollback spot. We want to have that as we're refactoring, because we don't want to accidentally break something and be totally messed up because we didn't branch out, right? So you want to be able to branch. You want to be able to do that. Another key tool for refactoring is an IDE. Now, there's a lot of different ways to use tools while you're refactoring. An IDE is infinitely very usable. Not so much because it has refactoring tools. Most of them do these days. Most of them have some built-in refactoring tools, but mostly because you're going to be doing a lot of search and find as you're modernizing your legacy application. Refactoring, you're not necessarily going to be doing a lot of searching, but when you modernize, you are going to be doing a lot of searching. And the IDEs have built-in functionality to allow you to create a project, and then you can search within the project for, different things, and it just makes it easier. Now, I don't want to get religious here. I realize there are other tools and other ways to do it, and IDE is just more optimal. And I talk to many developers who say, you know what, I'm a VI user, I'm a Vim user, I'm a Sublime user, and that's all good and fine. But use an IDE for your searching when you're refactoring and modernizing, and you'll thank me later. Even if you want to continue using those other things for your day-to-day coding, that's fine. When you put on your coding hat, you use those. When you put on your refactoring hat, use the IDE. It'll be much more optimal for you. Another key thing to keep in mind as we're modernizing and refactoring is to have some sort of coding standard, right? If you're modernizing, if you're actually trying to enhance the code of the application, you want to have some sort of style guide in the way that the code should look to make it more readable. We as developers spend most of our time reading code and a smaller percentage of our time actually creating new code and writing code. Myself, I have a benchmark of around 60% of my time is spent reading. 40% is actually spent adding new code. I mean, if you think about it, whenever we want to change something, we have to read the code around it to see what we're going to change. If we want to add new functionality, we have to figure out where we're going to put that new functionality. So we have to read code. So it's basically like reading a book. We're authors as developers. We author the code, and we're going to spend a lot of time reading it. So it makes it a lot easier if you're using a coding standard, so that way you know what you're looking at. It makes it easier to read because you get in the habit of seeing code formatted a certain way, and you can scan down really fast because you just get used to looking at it. So I encourage using some sort of style guide and coding standard. PHP Fig is a good one. I'm not saying you have to use it. It is the standard for most frameworks and most libraries these days. And it's a good starting point if you don't have one. If you decide to not use it because some people have this thing in their mind, I don't want to do it because everybody else is doing it that way. I want to do it my own way. That's perfectly fine, and you can do that. But make sure your entire team is following that same one you are. Consistency is the key. When you have a team of developers, everybody has to be doing coding the same way. They have to be doing the same styles and the same standard. Otherwise, you're defeating the purpose of having a standard and following it, even if it's a homegrown one that you've created for your own team. It allows us to read faster and allows us to have more of a united team as we go. Another thing that we want to make sure of as we're modernizing code is we want to have tests in place. If you do not have tests in place, you cannot modernize and you cannot refactor code. Don't even bother. You are effectively not even programming if you don't have tests in your code. So stop doing it, start testing. Now that being said, notice I said testing. I didn't say unit testing. Okay? I'm not against unit testing. I'm not going to force you to do it either. But you have to have some form of testing. Even if it's just an Excel spreadsheet with number 1, number 2, number 3, number 4, here's the steps that I'm going to test my code, that is a test, right? It's more of a functional test, it's more of a behavior test, but you have to have some form of test. If you don't have that in place, you have to make that first. Otherwise, you don't know if you broke something. You don't know if you altered functionality of the application, which refactoring should not be altering the functionality. You have to have the test to ensure and let you know if you did something that changes the functionality. There's a lot of different things you can use. I personally use many of them. I use Selenium, and I use the Selenium IDE add-on for Firefox, and that way I can record and then play back. I also, in some cases, I might use an Excel spreadsheet of number 1, number 2, here's how I do my testing. Other times, if the code is in a decent enough state, I can use PHP unit, something like that. Generally, though, for the purposes of this talk and what I'm talking about right now, we're modernizing a legacy application. You are not going to be able to use unit testing because the code sucks. That's why you're modernizing it, right? So it doesn't work. So that's why we want to make sure we have some sort of testing, even if it's just a bulleted list of here's things to fix. As we're modernizing, the steps that we're going to follow is, first we're going to tackle auto-loading, right? We have to create some auto-loading to modernize the legacy application. Then we're going to consolidate our classes in the same place and get all of our classes together. If we don't have classes, we're going to create classes. So that way we can get everything modular, get everything in there, more of an object-oriented approach. Then we're going to clean up any global usage inside the application, because most legacy applications use globals in one fashion or another. Then we're going to replace the new command, instantiation of other classes in some cases, if they're there. We're going to try to clean those up because we don't want instantiation to happen throughout our application. We want to kind of control where that's happening so that way we can more easily test and we know where things are going on. We're going to create tests. In this case, we're going to create unit tests after we get the code to a condition where we can create unit tests. It's important to do that once you reach that point and you're able to do it. You want to create automated testing. Then we're going to extract out any SQL commands. I often find that legacy applications, they weren't using some sort of abstraction layer, and even if they were using a framework, maybe they were using a query command and actually typing out the query longhand versus using abstraction. So we're going to clean that up. We're going to get rid of the SQL statements and definitely going to enforce separation of concerns and get our queries out of our business logic and things like that. We don't want them there. We want them elsewhere, and then we're going to call them. We're going to extract the logic, and then we're going to replace any remaining includes that might be sitting in our code somewhere. So these are the general steps of modernizing the application, and we're going to follow these. Now, for those of you who want to follow along, these slides right now aren't linked on Joined In. I will link them after this talk. I generally don't link my slides till after the talk because I want you to come see me. And then I link the slides afterwards so you can go and have a reference. But these slides will be linked up afterwards. Now, the first thing, like I said, we're going to do is worry about auto-loading, right? So we're going to create some auto-loading. In order to create auto-loading, we're going to have to look at it from a couple different standpoints. In modern PHP applications, we're using namespaces for that. Everybody using namespaces? Yep, good. It's good to see so many hands. I should see everybody, though, but that's okay. We'll work with that. Those of you who aren't using namespaces, you do know that PHP, if you're using 5.3 or newer, there is a global namespace already created, and you are using it in your code, whether you know it's there or not. You're still using namespaces. It's just a global space versus having it named. So that being said, we effectively are already using it if you're 5.3 or newer, which you should be 5.3 or newer. Actually, right now, 5.4 just went out of security support, so you should not be using anything 5.4 or older. You should definitely be 5.5 or newer. That way, you're actually in a supported version of PHP. So in this example, we're going to use PSR 0, which is the auto-loading standard for the PHP Fig. The reason we're going to use that, I mean, in a perfect world, we could use PSR 4, which is true namespace and a little bit cleaner, where your class names aren't huge because they're not also defining the structure of your application. But in legacy apps, we generally don't find nice, clean class names. We generally find really long class names where the underscores mean another level deeper into the system, right? So using PSR 0 in legacy code, that's generally what we have. So we might have a class name like my_long_class_name, and that translates to /my/long/class/name.php. It translates that way, and that's PSR 0 compliance namespaces, right? On the other hand, PSR 4 would be a true namespace where you would have, your namespace would be migrate namespace name, and then that would translate to the structure of migrate namespace /name.php. The name of the file is much smaller. The name of the class within that file is just name. And that's PSR 4 compliance. There's more to it than that, but let's stick with that for now. So that being said, that's our goal, is to make it auto-loading. Now, one thing that I didn't include up here, which if your code base is really old, or if it was really improperly designed, you may be to the point where you have to do some sort of class map auto-loading. And you can do that too. You can tell Composer to create a class map as well as PSR 0 and PSR 4 if you have to do that. When I took over the Ibm I Toolkit that I was talking about earlier, I had to start with class map. The reason I had to start with a class map is because there were some files in that legacy code base where there were multiple classes in one file. There's no way I could use PSR 0 for that. PSR 0 means you have one class per file, and I didn't have that, so I had to use a class map in that instance. It's still modernizing. Now my next iteration will be to break out those classes into their own files, and then I can go to PSR 4, and go nice and clean that way. But and that's what we're planning on doing with version 2 of that toolkit. But we have to get there. If you were in my keynote this morning where I talked about crawling and walking, crawling is modernizing. You're going to start crawling and you get up to the point where you're walking, right? So you have to do it slow. You have to get there. It's not something that you just do. It's something that you progressively get better. So in the auto-loading approaches, there's many different ways to include an auto-loader, right? So you can include auto-loader either through a global function. You can include it through some sort of closure, which is fast and it's lazy loading, so that's one way to do it. You can include it through a static or instance method, which is actually preferred, because then you're not doing globals and you're not doing anything else, because the objective in some of the future steps is to clean up globals, so why would we want to create one here, right? You can also use the _auto load if you're using version 5.0 or older, but none of us are using that version, right? So we're using something newer, so we shouldn't be doing that. And we also want to make sure that we have a central place to put all of our classes, so that way the autoloader knows where to go and find all of our classes. So that's the first step is we're going to follow is first we're going to move all of our classes into a central location. Now, in this sample application that I'm going to walk through, excuse me, we can see that I have a classes directory here that I created where I put my autoloader. I also have a food directory, a lib directory. In a legacy application, you're generally not going to find all your code in one place. It's generally not going to be neat. It's legacy. Over time, different folders have been created in different places to put our PHP classes. in our PHP code. So in this step, we're going to consolidate that. We're going to move them to a central location so that way we can clean things up and know exactly where our code is versus everywhere that the different generations of developers in that application have created. So we're going to try to clean those up. So the first thing, in order to do that, this is where our search feature comes in, right? This is why this searching is so important in the IDE. Is first thing we can go and start searching for include statements. And this is going to tell us where all of our classes are. This is going to tell us where all of our code is looking for these includes. And by doing that, in this example, we can see we have a require once here. Now, we're generally, at the moment, we're not going to mess with the setup. We're going to leave that kind of be for right now. But we are going to look for the require once. So we're going to see here we have a user.php. And then below that, we're instantiating the user, right? So we know there's a class there, and we know it is. So what we'll want to do is we'll want to create that central location, and we're going to move our user.php up to the new location in the class's directory. So we're starting to move everything into a central location. And then once we do that, then we can go back to our code, and we can clean out that require because it's not there. We're using the autoloader. We don't have to require it anymore, right? So we're cleaning up our code. We're taking that include or the require once out, and then we're still able to instantiate the user. And so we continue that. As we go through, that's just the first one. We continue to do our find search and find more include statements, and we continue to find them all, and we clean them up just the same way. We move them to the new central location, and then we move on to the next one. Move that one. So once you find every instance of require once or something like that, you clean it up, you move it to the new location, then you search for other places that might be including that same one. You clean those up. And before you know it, you've got all your classes in one place, and you've cleaned up where the instantiations are. Remember, at this point, we're not cleaning up the instantiations. We're leaving the instantiations there, but we're cleaning up the auto-loading of those classes as we're instantiating them. So we've got all that cleaned up, right? Now, don't underestimate that step. Again, this is just a really quick talk on this, but that could take a really long time if you have a lot of classes, if you have a lot of code. This is not a small step. You're generally not going to do this in an afternoon. It's going to take some time. You need to do a lot of searching, a lot of testing, because as you move these classes, your tests should not change, because we're not changing the functionality of the code. All we're doing is changing where that file is being included from. All of our code still works. All of our tests should still work exactly the same way. And then the next thing we target is our global usage, right? So global dependencies. The steps to clean this up, first we're going to search for any global usage. And this could be the global word, just calling it as a global. And it could be even super globals if you wanted to go that far, right? Initially, in this example, we're going to talk about just the global usage, the keyword global. So we search for global references. Then we're going to move the global call to the constructor inside that class. We're going to create a constructor if there isn't one, and we're going to move the global call into that constructor. After we do that, we're going to convert the global call to a constructor parameter, dependency injection, right? Just that simple. And then we're going to update the global call to a class, through that, and then we're going to instantiate the new class and pass the parameter like dependency injection, and then we're going to repeat that as needed. So as an example, let's take a look at that. We have an example.php. In example.php, we're specifying a global for our DB, right? We're calling the database, it's global. In legacy applications, this is generally what you're going to find, because the database is the first thing everybody wants to be global, right? They only want one instantiation of the database, and then they call it everywhere through global. And then we found that, and we know through the require or the auto loading, we know that the setup.php is where that's being called. That's where we're actually instantiating the database, and then we're calling it globally from here. So to start cleaning that up, we create a constructor, we put our global DB call in there, and then we call our DB, and we assign it to a protected variable within that same class, right? Pretty simple at this point. We're doing the same thing, we're just doing it within the constructor instead of within another function. And then down in our fetch function, we're still able to call DB because we put it in a protected field within our class. As a next step, then we would convert that call to a constructor parameter. So instead of calling it as a global, we're going to change the constructor to now expect that DB to be passed in. So now we no longer have to make the global call. We no longer have to instantiate it right there. All we have to do is make sure that the DB object is passed into the constructor. And then our fetch stays exactly the same. The assignment to our protected field stays exactly the same. That hasn't changed. Our tests don't have to change. We have the include statement where we're calling a setup. We're now calling example. We're passing the DB in because the DB is actually coming from this include setup. So it's already there. We don't have to play with it too much. After we finish cleaning it up, now we do a lot of searching. We go through and find that, and then we finish to clean up. And then after we've cleaned up globals, now we can start focusing more on the structure of our application and really start make sure that our auto-loading is used. So we want to start searching for new. We want to start searching for instantiations within our code base. And so we do that. We start looking. Now, if as the second step, we're going to extract that instantiation into a constructor parameter if it's a single use case or if it's only using it once. If it's using it multiple times, then we're going to extract that out into a factory class and call it that way. That way we can dependency inject it in. And then we're going to update the instantiation call, and then we're going to repeat as necessary until we clean them all up. So as an example, let's look. We have an items gateway class here. We have protected fields for our database credentials. We have the constructor where we're passing those, and then we're instantiating our database down here, right? So that's our current items gateway. This is the beginning. This is where we're actually instantiating the database call. Now, on the other hand, if we build the constructor inside that items gateway, and instead of passing all those database parameters, we've cleaned it up already where we're now passing the DB object, right? We're no longer having to instantiate it there. We're passing the DB object into the items gateway. And that's not if you have a single usage. It's pretty easy to clean that up. It's really all there is to it. However, if you have multiple instances, like maybe you have the gateway being called iteratively inside some sort type of loop or something like that. In that case, we're going to do kind of the same thing. We have our constructor. We're passing the DB in. Now, as a pre-thing, we can see here we have new item. We're instantiating the item within a for each. That gets very expensive, right? Because we're doing that instantiation call every single time it loops over. Alternatively, what we can do is we can create a factory. And inside that factory, we can do the instantiation of the item. Now we've got an object that is persistent. It's always going to be there, and it's going to have that item. So then we can go back into our code. We're including it in. We're calling our new items gateway, getting our database call, or actually that's before. And then afterwards, we're creating a new database. We're creating a new factory, and then we're creating a database, and we're passing the factory into the items gateway. And that's how we would do that. So now we don't have to reinstantiate it, for every single loop through. We instantiate it one time and recall it over and over and over again. It creates a much more consistent feel, much more testable feel. And then we can go back and replace our new inside of our thing. So now we have the items factory. We're calling new instance every single time. We're calling a new instance of it, and it's doing the instantiation outside. Just a little bit cleaner, right? And then we do our searching for more news, and we repeat it as necessary over and over and over again. This is a lot of stuff. We've covered a lot of stuff so far. So don't underestimate this. This takes a long time. Once we get to this point, our code's relatively pretty clean. Right? We've gotten rid of our globals. We've gotten rid of all the new calls. We've got auto-loading. We're sitting pretty well. So now it's time to go and write tests. If you didn't have unit tests, this is the time you're going to write them, right? Because our code is clean enough that we can now write unit tests. And this is where we do that. We go through and write all the unit tests for our code. If you don't like unit tests, then find somebody who does. But you definitely want to have unit tests at this point. You want to automate that. You want to make it to the point where now we can do that. And then we start cleaning up our SQL instances, or SQL. If there's a query inside your controllers or something like that, inside your function or inside your classes, you want to extract that out, create something somewhere else that you can call, doing those queries, normalize it in some way. We're generally going to search for SQL, move the statement or related logic to a gateway class, create a test for the new class, alter the code to use the new method, and then keep repeating it till we don't have any more SQL inside of our code. It's all inside the individual gateway classes. After we finish that, then we can start extracting logic. We can extract the logic out. We search for the gateway, or we search for uses of the gateway that we just created. We're looking outside of transactional classes. We extract the logic to transaction classes. We test it. We write new tests where it's needed, and then we continue to repeat until everything is completely cleaned out. At this point, our code's sitting pretty good. I know we've gotten there fast, though, right? It's pretty quick in a talk like this, but it's going to take a long time. If you have a larger application, this could take a year. This could take 6 months. It's small, iterative steps. These are one at a time. You're going to continue through all these steps until you get to the point where it's clean. And then we're going to search for any additional includes that are left behind. If we have, like the setup, for instance, we had the setup left behind. We're going to search for any of those that are left. We're going to search through them and get rid of them, move them out to somewhere else, copy the contents into new class methods. Maybe we don't have a class for it. Maybe it's procedural code somewhere. We're including it. We'll pull that out, drop it into a class. And it's okay to copy it out and put it procedural inside a class, inside a function within that class as a first step, right? And then you go back and refactor it in small steps to clean it up. After we've done this, our code is so clean, we can actually start implementing a framework if we were so inclined. Right? And you should be so inclined because it takes a lot of the heavy lifting away of your application. We should be implementing a framework, leveraging services and events and use Composer and all these great things that now we can do inside of our code base. It allows us to have less bugs. We can now speed up our development time. We have a more stable application. It's easier to onboard new developers, and it saves a lot of money because now we're spending less time reading code, more time writing code. We're spending less time with bugs. Everything else all around is just okay. And some of the difficult parts with this is that now, in order to do this, it takes time, right? So we have to ask our boss for the extra time. Can I have time to tackle this? And there's a couple of different ways to do it. One is just asking your boss outright for it. Another way is to do it incrementally. And as you're doing something inside the code, clean it up in little pieces as you're doing it. Leave it cleaner than you found it. It's going to make your life easier, so just try to nail it and get it done. Oftentimes, you're not going to get manager buy-in. Refactoring is as much a technical challenge as it is a social challenge. A lot of people are just reluctant to it, simply because they're not used to doing it. So we want to make sure that we're doing it. And then you have to make sure you go to the boss and get buy-in, right? So that way the boss will give you the permission to do it. There's generally a tech-savvy boss, a quality-centric boss, and a time-driven boss. Each one is handled a little bit differently. Tech-savvy is pretty easy. You can explain the technical parts to it, how easy it is, and generally they're going to come on board. Quality-centric, much the same thing. You're talking quality of code. They understand that. They understand the customers are going to be happier because the code's more quality. A time-driven boss is a lot harder to deal with because they're time-driven. They don't care. They just want it done fast, so you're generally going to have some trouble with them. But oftentimes I don't tell a time-centric boss. I just work it into my quotes. I just work it into my time because it's something I need to do. So with concluding thoughts, first, when it comes time to refactor in modernizing a legacy application, don't refactor a broken application. If it's broken, don't touch it. Fix it first, then refactor. Always fix it first. Now, I'm not talking about a bug. That's different. I'm talking about broken, okay? If it's broken, don't touch it. That's the worst thing you can do. You're only going to break it more. Have tests prior to refactoring. Very important. Not necessarily unit tests, but you want to get to the point where you have automated unit tests. But oftentimes, you have to refactor to get there. Do things in small steps and love iteration because it's what we need to do. That's all I have. Thank you very much for coming. Please rate the talk. Joined in, please rate the talk. I appreciate any feedback you can give me. You can find more information on me at geekyboy.com. That's my personal blog or my podcast that I have at Run Geek Radio. Thank you very much.